And welcome to another screencast, where at this time I'll be discussing the structure of the lungs, functional anatomy of the lungs, and so you should be able to identify, describe, and explain the location of the lungs, a little bit about the lobes, and then the structure and function of the pleural membranes, which are the serous membranes around the lungs. Okay. So a little bit of gross anatomy and some orientation here again. So we see the rib cage here, the sternum and the ribs that are forming the anterior and the lateral borders there, and then the diaphragm, which is going to form the inferior border of the thoracic cavity here. So the heart is here in the mediastinum, and then you have the lungs that are going to be lateral to the heart there. Right? And so we see again the heart surrounded by its pericardium, and then we're retracting here the lungs a little bit so that we can see that heart in the center. So this is just placing the lungs in the thoracic cage here. Now I want to again just point out this diaphragm is the inferior surface here, and this completely separates the thoracic cage from the thoracic cavity from the abdominal cavity there. Right? And the lungs are attached to the diaphragm here. The heart is attached to the diaphragm there, and the lungs are attached to the diaphragm there by their respective serous membranes, which we'll discuss in a little bit. So a cross-section view over here. So there's anterior. We see the right lung, and that is going to completely fill not only the anterior portion of that thoracic cavity, but also the posterior portion as well. So when you are going to the doctor, he or she will put the stethoscope on your chest and listen for your heart, but then we'll also put it laterally on either side, and then also go onto your back, put the stethoscope here, ask you to take a deep breath, so they're listening for air moving in or out of the posterior parts of the lungs as well. Many kids are surprised to see just how big the lungs are, and when you come to class and take them out of the mannequin, you get a good idea as to the three-dimensional relationship there of the lungs and how big they are and how much of that thoracic cavity they actually take up. Right? So if we look at each lung here, we look at the right lung and the left lung, they are both broken down into lobes, and again these lobes are divided by these little fissures here, and the fissures allow the lungs to expand a little bit better. So when we break them into these lobes, the right lung we see has three lobes: the superior, the middle, and the inferior, direction-wise. It makes sense. And then the left lung only has two lobes: the superior, and then the inferior. So the left lung is a little bit smaller than the right lung, and is shifted off to the left side a little bit. The left lung is. So this angle again right here is not equal. You have a little bit sharper angle here, a little bit more obtuse here, and that's because the heart is going to be in this area right here, and sort of moving to the left. So it displaces some of that left lung, and this little angle here is due to that as well. So as we're growing and developing, this is what's going on. The base of the lungs are going to be then in contact with the diaphragm again, which is the skeletal muscle separating the thoracic cavity from the abdominal cavity. Right? So these colored diagrams down here are not detail that you need to know, but just so that you are, just so you're aware that pulmonologists, people that study the lungs, will then further subdivide those lobes into subdivisions, apical, anterior, etc., for that superior lobe to be a little bit more diagnostic about where there might be a problem, either blocked airways, damaged tissue due to cigarette smoking, due to tumor growth, etc. So we have, we can subdivide those a little bit more. And again, this is detail that you don't necessarily need to know. The top detail, yes, but not the bottom. So the lungs are surrounded by serous membranes. And again, these serous membranes are actually very simple organs that are made of epithelial cells or epithelial tissue as well as connective tissue. Right? And if we are to take a close look, well, these serous membranes, first off, are called the pleura. Right? And so we have two pleural membranes. Right? So the pleural is the adjective. So two pleural membranes, one that's going to be right on the surface of the lung and one that's going to be separated by some pleural fluid that is then going to be attached to the underside of the rib cage or the diaphragm. So if we look at this detail over here, here we have the rib, right, and then this is muscle between the ribs. Right, so intercostal, inter is between, and costal is ribs. So anything costal is dealing with ribs there. So the membrane, the serous membrane that is attached to this chest wall is the parietal pleura. Right, parietal is wall. And then there's a space there, this pleural cavity, which is going to be full of pleural fluid. So we call this the pleural fluid. And that pleural fluid is secreted by the cells, these epithelial cells of these membranes. The membrane then it is attached directly to the lung tissue itself is the visceral pleura, right, or the pulmonary pleura. Most often you'll hear me just say the visceral pleura there. Right? So parietal pleura, visceral pleura, separated by the pleural cavity. So in this diagram down here, the blue part is the parietal pleura. The white spot, white in the middle there, is the pleural cavity with the pleural fluid in it. And then the red lines are the visceral pleura. And we see that the pleura go all the way around the lungs. Right? So we start here and go all the way around. They're going to go the entire surface. Here they're in contact with the diaphragm, right? And then the heart would be here. Right? And then right here the visceral pleura becomes continuous with the visceral pericardium. Right? It becomes continuous with the visceral pericardium. We'll show that on another diagram there. Right? Transverse section, again, orienting ourselves. Here is the heart, and the serous membrane around the heart is the pericardium. So here's the visceral pericardium, parietal pericardium. These then are the lungs. Right? So this is the visceral pleura. This is the parietal pleura. There's a little space here that's pleural fluid in the middle there. There would be pericardial fluid here. So we want to show that the visceral pericardium and the visceral pleura become continuous with one another right here. Right? And then this membrane is there. So when this heart is beating and moving, and when the lungs are beating and moving, they're kind of pulling on one another there. This parietal pleura you see is connected to the wall of the rib cage, right? Or sorry, of the thoracic cage there. The visceral pleura here on the surface of the lung will go down into the fissures of the lobes, separating some of these lobes, right? And then be continuous all the way around again. And there's pleural fluid that's going to be in between there. So being able to identify those, we can use some materials in the lab to look at with the mannequins and sort of model that as well. But here's the importance of these pleural membranes. Right? The importance of them is that the fluid that's between them, so in this pleural cavity there is fluid, and that fluid is hydrogen bonding to one another. There is surface tension between them. So essentially what's going on here is that this pleural fluid is helping to stick this visceral pleura to the parietal pleura. Right? So that's, excuse me a second. This fluid that's here is helping to keep the lung inflated. Right? So it's essentially sticking this membrane to the membrane of the that's attached to the wall there. So this intrapleural pressure is keeping that lung inflated here. Right? And these pressure differences, we'll talk about these in another screencast when we're dealing with ventilation and breathing. But suffice it to say that if this fluid wasn't there, the lung would collapse on itself this way, right? And you compress all those air spaces, and then it would be very difficult, in fact impossible, to breathe. Right? So again, these pleural membranes are extremely important. If you penetrate that pleural cavity with some sort of object, right, and that pleural fluid leaks out, you break that surface tension and the lung collapses, and that is called atelectasis, right, or a collapsed lung. Right? So a little bit of functional anatomy there for the pleural membranes as well as the lungs. So you should be able to describe here gross anatomy, location of the lungs, and a little bit about the lobes, and then information about the pleural membranes there as well. Okay, thanks for listening, and bring your questions to class.